What's going on, guys? Vlad here, and today we're going to be making a very cool application for our MicroLogix 1100 PLC. So what I'm going to be showing you exactly is how to work with inputs, how to work with outputs, and we're going to be doing a demo on an HMI screen, which I actually have on your screen right now. And we're going to be controlling a very simple process, which is actually quite simple, but it explains a lot of the basic principles that you need to know in order to program PLCs. And what I'm talking about exactly is how to read a digital input, process that input, and work with multiple inputs at the same time, then latch in certain inputs and then process the output based on a very straightforward algorithm, but that comes up very often on PLC interview questions. So let's jump into a quick demo of the project that we're going to be building. And as you can see, I have a screen which is essentially a FactoryTalk View application test screen. And what I have here is a tank as well as a valve and 3 buttons. One which is going to be for starting the process, one is going to be for stopping, and the last one for resetting the process. And what the start button does, as you would expect, it controls the valve which feeds the tank. And when I press stop, as you can see, first of all, the output does get energized on the PLC, and then this valve starts filling the tank. Now the tank fill percentage is going to be displayed on a nameplate, but it's also going to stop the valve once the tank has been filled in order to prevent spillage. This is very basic stuff that you would need to do as a PLC programmer. The other thing is that you can stop the process at any time, so you can stop filling the tank at any percentage as soon as somebody or an operator essentially presses the stop button. And last but not least, you have a reset button which resets the tank, or essentially empties out the tank just for demonstration purposes. So you can reset the tank. As you can see, the tank fill is back to 0%. You can start the process again. Our valve gets a green highlight once it is open, and you can stop at any time. As you can see, we are right now at 55%. And you can restart the process up until the tank goes up to 100%. And once again, do notice that on the PLC side, you are actually getting that output. And I'm going to be showing you how to work with hardware inputs, as well as kind of dab a little bit into how software inputs are handled through an HMI, because it is quite a bit of a difference. And nowadays, most of your PLC systems are going to be digital, meaning that you would control through an HMI versus, controlling through a hardware button, which you would see on older type systems. That being said, you still have a lot of flexibility in terms of which route you decide to go. And going back to the demo, so you can continue filling the tank up until it reaches 100. And as you can see, the PLC automatically turns off at 100% fill. Your valve gets turned off, and you can no longer start the process. You cannot overfill the tank essentially through very basic logic on the PLC. And again, you can stop, you can try and starting, but you cannot do anything until you empty out the tank, which is exactly what you want to do in a real industrial manufacturing setting. Once you've reset, however, you can once again start and stop as you wish. So let's jump into the hardware portion of this tutorial. So let's first talk about the connections that we'll need to make on our PLC side. And we're essentially going to be discussing how we need to set up our inputs in order to accommodate 2 buttons, which are going to be start and stop for our process. I'm going to be walking you through the exact steps that I would use to set up my inputs on the PLC side. So if you want to look at the PLC right now, as you had noticed from my previous video, there's going to be 10 distinct inputs that are allocated for this particular PLC. And if I zoom in a little bit closer, you will notice that there's going to be 2 distinct buses. So you'll see this bar across input 0, 1, 2, and 3, as well as a bar across inputs 4 through 9. And these buses essentially signify which isolation or which kind of an input scheme you're going to be using. And what I'm referring to, and I'll have the data sheet put on the screen right now, is essentially if you want to configure your inputs as syncing or sourcing. And essentially what you need to know is that your DC common, so the first pin on each one of these series of inputs, is going to dictate if you're going to be using a syncing or sourcing scheme. And in order to use a syncing scheme, we're going to be having to pull down that DC common to low, which I'm going to be doing by putting this little jumper from the DC common down to our 24 ground bus. And essentially, you need to be aware of this. And what this does is essentially allow you to switch that input by driving a voltage high to through the button and into the input. If you were to create a sourcing input, you would have to drive a negative signal instead of a positive one. So once that's set up, and this is a very critical step, if you do not put that jumper in, your inputs are simply not going to work. And what we can do now is essentially do a quick test. So if I put a jumper between 24 volts and let's say input 3 here, or input 2, you will see this very faint bar on the LCD screen which lights up, indicating that that input is being activated. So right now our input 2 is high. If I remove this jumper, the input is low. So it works just on just the same way as on a microcontroller, but essentially we can test inputs like that. So this is input 1. As you can see, I'm putting in 24 volts to that input and it's lighting up on the LCD screen like you would expect. So those are the kind of the basic setup of the hardware on the PLC side when it comes to inputs. Let's now turn our attention to a simple industrial button and quickly discuss its functionality, as well as which connections we're going to have to make to the PLC in order to make our program work. So on a button, you will typically have a set of contacts which will either be normally open or normally closed. And on an Allen-Bradley button, you will actually have both of these contacts, and you can add through mechanical means more or less of these essentially blocks which you can use for your needs. Furthermore, on this particular button, you also have an LED inside, which I can show you really quickly. If you remove this top as well as the colored lens, you will see that there's an LED inside, which lights up depending on your outputs, and you can program your software to turn on and turn off that LED depending on the indication that you're looking. So for example, if your machine is running, you can have a green button which is illuminated. But more about the mechanical setup. So if I approach this really close to our camera, you will see that the top set of contacts, it's actually internally, if you look at, there's a little metal bar which is currently connecting both of those terminals. As you have the button unpressed, it's going to be connecting those terminals. So as I press the button, you will see that that bar is going to travel and connect both of the bottom terminals. So what that means essentially for us is that the top set of terminals is normally closed, whereas the bottom set of terminals is normally open. Once the button is pressed completely, right, so not in this middle range, but completely, it inverses the polarity of both of those terminals. And what I typically want to do is connect the button based on the state that it is pressed, right? So you can obviously read the top set of terminals or the bottom one, but I have a preference to connecting the bottom ones because it is the actual pressed state. So what I'm going to be doing is essentially putting a set of cables, and all you have to do is put a cable inside of that terminal and tighten the screw. So I'll do that on terminal 1 as well as terminal 2. And as you would expect, all that really does is create a zero resistance once the button is pressed across those terminals. And on the PLC side, if I connect both of those terminals back to the PLC, so one of them is going to have to go to an input. So I'm going to be using input 0 for the start button, and I'm going to secure that on the PLC right here. So that's going to go into our terminal 0. And the other side, as you remember, based on the fact that we're syncing our inputs, we're going to be putting on 24 volts. So if I connect that to 24 volts, tighten down the connection on the PLC side, and now we can start looking at our input. So I'm going to just zoom in a little bit so you can see the signal on the PLC screen, and I'm going to move in the button, and as soon as I close, as you can see, as soon as I touch those terminals at the bottom, input 0, which is going to be indicated on that screen, is going to illuminate. So as the terminals are essentially shortened to 24 volts on the PLC side, you have an indication on the PLC that the hardware has been activated. All right, so now that we are online with our program, we can see that we have a blank program called the main, And I have essentially a few utility programs that are running as well, and I'm going to be kind of going over that a little bit, but not into too much detail for the purposes of this tutorial. But what we're going to be starting to look at is our inputs, right? So we've connected one button across our input 0, and we need to make sure that it works. So if I press the button once again, you can see in your program that this 0 switches to a 1 as soon as the button is pressed. And what we can do right away is, since we know that's working, we're going to give it a description, which is going to make it really easy for us to reference the buttons in the future. So this is going to be our start button. I'm not going to be putting in a stop button, and I'll explain the reason for that soon, but essentially we're going to be thinking that our stop button is going to be on pin number 1. So this is going to be the stop button, and the third button is going to be the reset button. Right, so it's just for the purposes of a tutorial, but I'm going to be virtualizing those buttons on an HMI. In terms of outputs, as I mentioned before, we are going to be driving a hypothetical valve, so I don't have a large tank which we are going to fill with water, unfortunately. So what I'm going to be doing is this output, which is going to be driving the output 0, I'm going to give it a description of tank valve. So this is going to be our tank valve. It's going to be the first output. And one thing that you need to kind of notice is that if we switch this to a 1, again, on the PLC, on this indicator, you will see that this goes to high, which essentially opens our valve. And a 0 is going to mean a close in our program. So if we close out of those windows, we can start our program. So the first rung that we're obviously going to need to add is when you press the start button, the valve needs to energize, right? And the way you do that is you include an XIC, so examine if closed instruction. And remember, our input is the start button. So you can copy this address, which is going to be, right, you hit on copy, which is going to be for our start button, and you can paste it right into this window, hit enter, and that's our start button. Now it needs to energize the valve, and the valve, once again, we've assigned that to be on this the first output of our PLC. So once again, we can copy this and put that as the address of our valve. And as soon as we do that, we realize that we have a program which, when the start button is pressed, the tank valve is being opened. And if we verify our program and we compile our rung, test the edits, and then we say that yes, assemble the edits into our program, you will see that as soon as you press this hardware button, the tank valve is going to open. And do notice that there is a clicking relay as well as that output being energized, which essentially opens that valve. And here's the first problem that we have with this programming, right? Is that you have to hold this button in order for the tank valve to stay energized, which is not what we want, right? We want the valve to actually be sort of maintained and the operator not having to hold that button. And a lot of times in industrial manufacturing, you don't have buttons which latch in. You always have kind of momentary push buttons, and you can always create that on software. But essentially on the PLC side, what you would need is a branch around the start button which maintains the output to be energized when the valve is open. Right, so if we can copy this instruction, and here's another way. So if I put it on this rung, now remember this is an OTE instruction, so that's not what we want. We want it to be an XIC, which is examine if already closed or operational. So we're gonna press on change instruction type, and we're gonna put in XIC. Right, so this creates a condition where if the start button is pressed, the tank valve is going to be energized, but if the tank valve is already energized, the tank valve is going to remain energized, if that makes sense. So we're going to assemble, we're going to test our edits, and we're going to put them into our program. So watch what happens now. As soon as I press the button, our program latches in the tank valve, right? So as soon as the start button is pressed, the tank valve is energized and remains energized because it has been energized, right? Now, here's the next problem. The problem is that you can no longer do anything with the start button, right? So the tank is being hypothetically filled without a stop or any condition to stop. So what we need to introduce next is a way to stop this, essentially a way to stop this process. And what I'm going to do is essentially re-edit this rung. And as you remember, we have a stop button which we've hypothetically put on input 1. So what I'm going to do is examine if open, right? So this is going to be the reverse. So when the stop button is not pressed, we want to be able to start, but when the stop button is pressed, we want to be able to stop this rung. So what I'm going to do is, once again, this is an input. It's an input 1. As you see, it's labeled stop. I'm going to copy the address of this input and put that into our condition. However, as I've mentioned before, we're going to be virtualizing these buttons, and I have that program running in the background, which, as you remember, can be used for stopping and starting and so on. And right now, these buttons aren't doing anything. Well, first of all, because the tank is filled, but also the stop button is not linked to our start. So let's also look at how you can link those buttons to an HMI. And if we look on the left side, again, we have the data files, and you start off with output, input, status, binary, timers, so on and so forth. I'm not going to go into too much detail, but the binary files are what you want to use for your buttons or on-off signals. So if I go into binary, I can assign these buttons essentially to anything I would like, and then I can link them to the HMI. And I would want to keep the same notation, so my 300 is going to be my start button HMI, right? So that's going to be our screen button, and the 1 is going to be the stop button HMI. So we have the start and the stop on the HMI side. Now, what you can do if you have two stop conditions, right? So if you have two different stop buttons, you can simply add them in series. So what I'm going to do here is I'm going to copy and I'm going to paste a second button, but you need to be careful because this is based on our input, but I want it to be based on the button which is on the HMI. So right now I'm going to copy this and I'm going to put this into this tag, right? So now what our process is going to be doing is essentially starting when none of the buttons are pressed and then staying on until one of the buttons is pressed. I'm going to verify, I'm going to test my edits, and I'm going to assemble this into the program. So now what happens is, if you can see that the valve is always energized. Now if I hit this stop button on my HMI, you will see that first of all the valve went off, but if I switch back to RSLogix 500, you will see that this button has been pressed and the tank valve is no longer active. And again, just to demonstrate this very basic program, if I hit the start button, you can see that the start button energizes because none of the stop buttons are pressed and the tank valve goes on. Now because the tank valve has gone on, it will now be made through this particular branch. And that essentially creates a very simple program which allows you to start and stop the tank valve. And just to confirm this on the PLC side, if you wanted to stop this process through a button, all you would need to do is essentially complete the circuit through, instead of being into 0, your stop button is going to be on 1. So I'm going to be essentially removing this button from 0 and putting it on 1 just to demonstrate that you can stop this circuit very easily, just like you did with the HMI button, right? So now it's on 1, and I'm just going to tighten this screw really quickly. And as soon as I press the button, you should see the stop button bit being unlatched, right? So now my hardware button is essentially the stop button input 0, 1. And obviously, if you wanted, you could connect both of the buttons and then you could have a start and stop condition. You can also, what you can do is essentially you can toggle bits in your Logix, and if you can see, if I've toggled the tank valve, obviously this rung gets made, right? So this is true, and this is true. So the tank valve is being energized. As soon as I press the stop button, this bit goes high, and the rung is no longer true. So that essentially concludes our tutorial on creating a very simple tank valve system. I'm going to be expanding on this in a future tutorial where I'm going to be talking, more how to interface the HMI and how to link both of those tags together, which is a process in itself. So if you've liked this video, make sure to leave a comment down below. Make sure to subscribe to the channel, and there's going to be a lot more to come when it comes to industrial automation. Thank you guys for watching, and see you next time.